Hi, welcome to Integrated Science. I'm Miss Sparks. Today we want to go over and introduce how to use our kinetic energy formula. And so you've been assigned this worksheet, and we're going to go through just one or two problems so that you can see the process. I like to think, unfortunately, this is probably, or fortunately, this is probably the most difficult equation that we are going to use in this class. And it only gets a little bit messy because we can use that square root, and you can see it here, but I want you to ignore how they've manipulated these problems because we're just going to stick with the one that we're really familiar with, which is kinetic energy equals half of the mass of the object and velocity squared. And so once again, when we're talking about kinetic energy, we're looking at things, objects that are clearly in motion. They have some type of movement to them. It could be a fast movement, it could be a slow movement, they could be speeding up, they could be slowing down. But we're going to just be looking at how can we find that quantitatively? What can we learn about this that's going to be really, really helpful? And so we're going to start with just working through some of these problems. So for example, number one says, what is the kinetic energy of a 5 kilogram bowling ball traveling at the speed of, class change, at the speed of 1.2 meters per second. So let's just go through and think of this as your T-chart that we would normally set up. I'm not going to draw one because clearly you can see that my handwriting with the marker is not so great. So, but let's go through and just kind of figure out what we've been provided with. So kinetic energy, we can see what is the kinetic energy here. So we do not know the kinetic energy, but they did give us 5 kilograms and 1.2 meters per second squared. So we can fill in everything and solve for it. So kinetic energy is our unknown. We don't know what kinetic energy this bowling ball is possessing, but we do know the mass. The mass of this bowling ball is 5 kilograms, and we do know how fast it's going as well. They've told us it's 1.2 meters per second. So then what we're going to do is just plug that into our equation. So I'm going to write it out one time and then kind of cut and copy it. So KE equals 1/2 of the mass times velocity, and we square our velocity. And Cami does have that for us, right? There we go. Perfect. So now what we need to do is look at how can we plug this in and solve. So this one's pretty straightforward. No manipulations or anything. So X is now our kinetic energy, and we are going to take 1/2 of the mass of the bowling ball, which is 5 kilograms. And we are going to multiply that by the velocity squared. So 1.2 meters per second. Kind of think about that. We're going to square it. Distribute our square. All right, so now all we have to do is simplify. So we're going to take 1/2, and grab my calculator, 1/2 of 5. I should have been able to do that in my head. 2.5. Oops. Let me write the whole formula out though for you. X equals, now we know our 1/2 of 5 is 2.5 kg. And we are going to take 2.1 and square it, which you can use on your calculator, or if you just want to take 2.1 times 2.1, that is fine. Still the same concept, and I get 4.41 and meters per second. So now all we have to do is simplify one last time, which is just multiplying now what we have found in our parentheses. So we're going to take 4.41 and multiply it by 2.5. And I end up getting 11.025. X equals, so 1/2 of 5 is 2.5, 2.1 squared is 4.1. I'm going to double check that. There we go. And when we multiply those together, we get 11.025, and that is joules, our energy that we're using. So that's our final answer. We found kinetic energy. Hooray! So I'll plug it in right there. Perfect. Let's do another one. Let's jump down here. This is a good one because we have to manipulate just a little bit. So the question that is our task to solve is, what is the mass of an object with a speed of 12.5 meters per second with the kinetic energy of 312.5 joules? So we're solving for m this time. Ooh. See, that's why I don't use the drawing very well. It's nothing is straight. Got a crooked hand. So kinetic energy is going to equal 312.5 joules. The mass of the object is r unknown. We don't know that, so we're going to put an x. And then the velocity that this object is traveling at is 12.5 meters per second. Perfect. And so, you can see I kind of did some down below. There we go. So now let's plug in. Let's solve. This one is a little bit more of a manipulation. Not too much, but just a little bit more. So KE, we know that we're going to plug in 312.5 joules for kinetic energy, and that equals 1/2 of our mass, which is x. We don't know that variable. And we are going to square our velocity, which is 12.5. And I'm going to put a 2 behind it, and I'm going to make that superscript. There you go. So here's our equation. So looking at it, we need to simplify. We need to simplify what's in our parentheses first. So half of x, we can't do anything with that yet because we don't know what x is going to be. But we can simplify this 12.5 squared. So let's start there. So I'm going to rewrite my formula so you can kind of follow along. Equals still 1/2 of x, and we are going to square 12.5. 12.5 times 12.5 is going to give me 156.25. There we go. So here's my new equation, and still want to get x alone. And so think about, this is multiplication right here. It's this, the order of operations are telling me I should multiply this with this. Well, I can't do that just yet. So I'm going to get rid of the 156.25. And to do that, if it's in multiplication, we have to do the inverse of it. So we're going to divide. We're going to divide 156.25 on this side as well as 156.25 on this side. And I know that doesn't look very, I don't know, it looks weird to me when it's written out like this on the screen versus handwriting it out. So just think that crosses out on this side, and we're just going to finish up what we have over here. So now we're going to take 312.5 and divide that by 156.25. And I get 2. 2 equals, I still have that half of x. Almost finished. However, we are not complete just yet. We still have this half that's connected to this x. So think, we once again have to do the inverse. The order of operations says to undo multiplication or division. So think about this as, it's kind of written as, let me grab my whiteboard, if you want to think about it. Mathematically, it kind of should look like that. So in order to get rid of that half, we have to flip the half and make it 2/1. So we're kind of saying we're going to multiply it 2/1. My marker is dying, so I apologize. That looks really 2/1. So we're flipping the half, or multiplying by the 0.5, if you kind of want to think about it that way. So we're going to take this side and multiply it by 2. And the same over here. I'm going to multiply this side by 2. So this now cancels out our half here and our 2. And so now we're just left with 2 times 2 equals x. And so 2 times 2 equals 4. So 4 equals x. And so then once again, what were we solving for? X was our mass. So 4 kilograms. That is the mass of the object. And if you were to plug that back in, that 4 into here, and do all this work, you should end up with 312.5. And so kinetic energy is one where we kind of do have to manipulate. So the best thing to do is think about, what are my givens, write your T-chart out, figure out what is my variable that is missing, and then plug in using the order of operations. So hopefully this was helpful. Thanks.